Okay, so this is the newest tutorial for my OpenGL series, and we're going to do textures today. Let's see, in the tutorials, let me do it like this, or rather like this. There's 5 different chapters here so far, and now we're on textures. I don't remember. I don't think I've tested this yet on Windows. So right now it's only Linux, but yeah, I'll test it on Windows and Mac soon. But for today, just on Linux. So let's see here. Yeah, chapter 5 here, and we've got the binary that gets output. We've got a directory of assets which simply has my channel logo that you're going to see. That's the texture I'm going to output. In headers, we just have a shader.h. If I go like this, we'll see some stuff. Yeah, shader.h. The shaders, there's a vertex and a fragment shader. We'll look at those later. Got the main.c, and then we've got 3 run scripts depending on platform. And that's everything for now. Now I'm going to kind of go through most of the code. I'm not going to go through like the shader.h file. You can look at other past videos I've done for that. I will look at some of the shaders here, and you can get the code on GitHub. Let's see here. If I go like this, yeah, here's my GitHub, so you can go there and download the code. It might work out of the box for you. If you're on Windows or Mac, I believe up through chapter 4 should be okay, but right now just Linux on chapter 5. You can try to adapt the code for your platform. Okay, so let's take a look up here. This is the same directory, and let's take a look at main. Also, I added the image library, which is STB. We'll be talking a bit more about this later. Right now I've got it. So in this project directory, there is, let's see here. So if I go up a couple, there is the libraries directory. So in there, we've got our glad directory, glfw, and stb, which is our image library. I forget what it stands for actually, but whatever. And okay, so that's the one I'm using. And if you're new to it, you might want to look up, basically there's a GitHub repo for it, and it has these kinds of instructions in the README. So if you're new to it, you'll want to check that out. Just look up stb image library online and you should find it. And it's meant to be kind of minimalist basically, and in terms of speed it should be alright and stuff like that. Anyway, so and it's the same library that is used on the learnopengl.com tutorials if you use those. Alright, so we're if we're in Windows or Cygwin right now, we are including glad. Now I believe I'm gonna have to start including this for Linux in future videos, possibly for more functionality. And okay, standard.io, glfw library. Per the documentation on GitHub, the image library requires this before doing this. I think, not sure if it needs to be the line before, but it needs to be before. So, and then we've got our shader.h. Again, look at previous videos if you want to see about that. We're in C here, not C++. Although soon I think I'll be defining true and false, but right now I'm just using 0 for false here. Right now I've got full screen as false. Let's just take a look at what this outputs here. And that's it. I've got my channel logo. You can resize it. Yeah, it starts out at 600 by 600. Well, I'm using a window manager, so it starts out sort of like that, and you know, it fits what the window manager tells it to do. But if I turn it into a floating window, it will go to the sort of default dimensions there, 600 by 600, and there it is. So it's kind of a low res image. I thought about making higher res, but I don't know. I kind of like low res in the beginning. Looks okay. So yeah, that's what we've got. So I'm also not going to go through all of the vertex array object stuff, or most of the Windows stuff here I've talked about in previous videos. All this is still Windows, creating the window and all that, and GLFW setting the context. We've got some glad stuff here, and then we end the Windows setup. But then, okay, there's this function for setting up the vertex array object, for binding it. And in this kind of simple program, you know, you might bind it in this setup VAO function and just leave it, because we're never really changing things around. But you know, normally you might switch to using different vertex array objects. For example, if you're rendering a cube at one point and then rendering a rectangle somewhere else. So just for sort of I don't know, good practices sake, I've put this here, not in this function. All right, and then I've talked about this before, but I'll just say again, we've got this, the way OpenGL works is it kind of, how shall we say, I think of this as handles. You know, it's like this quad shader is the name of my shader, but in under the covers in OpenGL, it's treating it like an int, and it just passes around these ints that it uses to identify your different shaders and stuff. And you see this kind of pattern often. So I call this a handle. I think that's what other people call it as well, but there's a lot of different ways that people talk about things. The build shaders function that is in the shader.h. Oh yeah, so I was going to rename that to build shaders.h. That'll probably be in the future tutorials. And it simply takes vertex shader and a fragment shader. Then we use the program. In future videos, we'll be doing stuff with various shaders, so you'll get a sense more of when to, you know, switching around using different shaders and so on. Okay, so I've got this. Again, this is, I call this a handle, the channel logo. It's just a uint. If you, I guess GL uint ends up just being a uint. It's like it gets defined that way as a macro or something. That's what I think. So it's basically the same thing as a uint, and so we'll be getting into this function called get texture handle that I made. And again, because I call it a handle, that's how I like to call it. I could say, maybe I've named it something like build texture or something, but I don't know. I like this terminology of calling it a handle, and calling it a handle, and this function will get a texture handle and pass it here. And so it takes the relative address here, or the relative path of the .png file, and you can of course experiment with adding in whatever image you want. Then we bind the texture, the channel logo texture. Also, like with the shaders, we'll have examples in the future with multiple different textures. It's always good after you've done something once to try it several times to get an idea of how it works. You know, kind of juggling multiple instances, if you will. Then this line is just for having opacity. Yeah, it's just a little thing that you can copy paste into your projects. Okay, I'm I've got these variables for window height, or sorry, window width and window height, and I get them here with this glfw sort of built-in function, if you will. And yeah, it passes the information into those variables. And I'm setting this GL viewport. To be honest, I kind of forget already. I wrote this code maybe a month ago. Kind of already forget why exactly I'm doing this, but I'm sure I'll remember. It's kind of important. I think that maybe like things don't, I'm just speculating, but you know, things nicely, they nicely scale, right? And yeah, we can experiment with what happens right here. Let's try that. See what happens if we turn that off. And I'll switch to compiling, so it's run Linux and then takes the argument. Yeah, so you can already see for whatever reason it's not getting the dimensions here. So now it's fine, but it doesn't scale. Okay, so that's why we have this GL viewport thing. It sets the viewport in OpenGL, which tells it basically the dimensions of the viewport. All right, so a little printf, don't really need it, but anyway, clear color, that's setting the background color, if you will. Clear a color bit. I think maybe we need to be clearing a depth bit. We'll do that later. Right now it doesn't matter. And then we draw it. And this swap buffers thing, I think I've talked about before. I might get have some videos more into the details of what's going on under the hood. Looks like I may have added this pull events. Actually, no. I've been working on it's not in there yet. I've been working on future future versions of the code, and I've already got input set up like with a gamepad, and so anyway, we'll see that later. I delete the program, little memory management there. They say it's optional, but I don't know. I might talk about that more in the future. But if you're familiar with C, then it should be obvious to you. And some glfw terminate function that does some cleaning up of resources. Okay, so I've gone through this VAO function before. I think that I switched the textures maybe. Or sorry, this is new actually. Yeah, this is new. And there's something a little funny that we got to talk about. Let me make this full screen here. And yeah, so it's kind of a big function. But before I talk about, let's just dive into the texture function here. And then I'll talk about this changes here to this function, and then we'll talk about the two shaders, and that should be it for this video. But yeah, let's talk about this one. So we just create a uint. That's what is going to be returned at the end. Remember, it's it's a uint, and we have this kind of standard workflow that we do in OpenGL in many cases, where we generate something and then we bind it. So we ask OpenGL basically to generate this texture, and we point to our texture handle, and then we bind it. Okay, so that all upcoming operations now have effect on this texture object. There's a couple of different options with the texture parameters here. There's clamp to border and GL repeat. I guess I'll try to add that to the end of the video to show you what that is. And then let's see, texture filtering nearest. I'll show that at the end of the video. Just some different options you have. And you know, I've left these in here that you can like this might be useful sometimes, and you would just comment these two lines out, comment these ones in to switch. So I've just left it there. There's other options. We'll talk about them. All right. there's mipmaps, and I'm generating the mipmaps here. Mipmaps, I might go into more detail in the future, but basically it's like a smaller version of texture. So, and usually so there'll be a version that is half the size, and then a quarter size, and 1/8 size, 1/16 size. And so using mipmaps can be useful for various reasons, which I might get into more later. And all right, so now we have there's this part where we set flip vertically on load. When we load in the image, actually flip it upside down. Now there's different ways of doing this, but there's basically a problem that you have to solve in one of many different possible ways. And that is that in the world of images, or maybe it's the world of image loading libraries perhaps, but I think it's just kind of the world of images. The 0.00 starts at the top left of the image, and 0.11 would be at the bottom right of the image, for whatever reason. Now that's not how we think in OpenGL. In OpenGL we think in terms of the 00 point being at the bottom left and the 11 point being at the top right. But you can kind of think of it differently if you want to. I think I was doing some OpenGL stuff like in Xcode using Swift and stuff, and maybe I was doing it thinking of 00 being at the top left and 11 being at the bottom right. So you kind of do have that option. But if you're looking at OpenGL stuff online, and if you're looking at the specifications for OpenGL and stuff like that, I mean, pretty much always, almost always, you're gonna be talking about 00 being at the bottom left, like when you did math in math class, right? And 11 being at the top right. So usually OpenGL does it like that. That makes a heck of a lot more sense to me. It's easier to think like that. But then, you'll find people on the internet, and it's a different way of looking at things, that will say that the texture coordinates will be 00 at the top left and go 1 to 1 at the bottom right. Those are the texture coordinates, and we usually call those UV for whatever reason. And I guess to contrast from XY, we might call XY our like window coordinates or something, and then the texture specifically, we wanted different names for those coordinates. And so even here it's S and T, so that's one way of doing it, but I would rather stick with the 00 being in the bottom left, the normal OpenGL way and the normal math way, as much as I can, including when I'm talking about textures. And so one simple little thing to do is just to flip everything upside down when the texture is loaded in, and then we can always think of the texture as having 00 at the bottom left and 11 at the top right, and we can just stick with that. And we don't have to deal with multiple, actually you're going to see we're already dealing with enough coordinate systems as it is, and you just make things, in my opinion, extra complicated, extra hard on yourself when you're dealing with texture coordinates that are 00 at top left. I think that's extra confusing. So the cost here is that this takes a little bit of time when you're loading in the texture. You got to flip it upside down. Of course, you could do this manually in various ways as well, but the STB image library has this flip vertically. The soil library, SOIL, that I was using before, and the old learnopengl.com website, it used to use the soil library. I guess they also have a function for that. But anyway, it's nice that they have this little function to make it nice and easy in the code, kind of elegant, if you will. Of course, 1 just means true here. So it's flipping it vertically when we load in the images, and we can remember that it's doing that. You can see it right here, and we can remember that costs us a little bit. I think it's worth that cost. Again, there are other ways of doing things. For example, and I used to do this, I used to just flip the y-axis in the shader. I forget if I did it in the Vertex Shader or the Fragment Shader. And you know, or at other times I believe I've flipped it here in the texture coordinates. So those are really your main other options. And the way I used to do it really bit me sometimes when I'd get confused about what the heck is going on, and then you've got to dig into your vertices and look at them, and you got to look at your Vertex Shader and your Fragment Shader and get all confused about which direction things are headed. Because if you're using what we're calling texture coordinates later, we're not going to just use them as textures. We're going to use them, like you can ignore the texture element of it and just make a shader with a bunch of calculations based on the X and Y values. And I want to do some ray tracing stuff, and we're going to do that. So that really has nothing to do with textures. And so if you were doing that, then how can I explain? You would need a different shader for doing that stuff normally, and then for doing the textures if you're not flipping them here. By flipping them here, it's like this is where it gets converted to the logical way of doing things. 0, 0 at the bottom left. It gets flipped here. Then we've got that. We don't need to worry about it again. And everything we do can be 0, 0 in the bottom left, and it can be consistent. If we don't do this here, then we're going to have, well, our textures are upside down basically, and we're going to have to think in those terms that our textures are upside down. And either we're going to have to flip this in a way that makes sense, does not make sense, and then later we're just going to have to remember that it's flipped upside down. You see, it becomes a mess. So we'll go through this. We've got top right is 1, 1. That makes sense, right? Bottom left is 0, 0. Bottom right, 1, 0. Top left, 0, 1. So standard X, Y coordinates like you learn in school. And there's a couple more changes in there we'll go over. All right, so the image is a pointer to an unsigned char, and we load it in there. And so it contains some data. Then GL text image 2D. And this basically creates the texture, I believe. You don't need to really be an expert on all this stuff, but yeah, we're just making the texture, and we're choosing RGBA. So we've got alpha there. We've got a width and a height. And so our image library tells us the width and height here and the number of channels. So I'm pretty sure that's whether it's like 3 channels for RGB or it's 4 channels for RGBA. So later we can handle, if we need to, we could handle some images that are just RGB, some that have RGBA as needed. But right now I just have one thing going on to keep it simple. Yeah, you can look at, just Google this and find the like Khronos docs that are out there. Khronos is the organization that makes the OpenGL specification. And that's what it is. OpenGL is a specification. And I forget off the top of my head what every little thing is, what this is. But you can look it up, and then we generate the bitmaps. We free the memory via our image library. Then we unbind the texture so that if we do this for a bunch of different textures, well, I don't know, it's just good practice. We unbind it, and we return the texture handle. Now in here, there's a couple of changes because we're going to have a new attribute here, the text chord attribute, and we're going to see this in the Vertex Shader. So the way it works, and I think for the collections, so there, on top of the tutorials, there's also a collections directory. I don't think there's anything in there yet, really, but I'm going to have like little interesting things in there, maybe things that aren't necessarily part of a linear tutorial series, but that aren't interesting. And one of the things that we can do is, maybe you've seen like this sort of rainbow colored triangle before. You can imagine like a Pink Floyd like prism kind of thing going on, but it's just a triangle with different colors. We could add as an attribute a color setting, and so we could have our positions would be like 3 floats, then our textures are 2 floats, and we could have 3 floats RGB for colors, or even RGBA if we wanted to, 4 floats. And you can see the structure, it's per vertex here. Positions, textures, positions, textures, positions, textures. So per vertex is how it's structured. You don't do, 4 positions and then 4 textures or something like that. And you also don't have separate array for your data. So that's how it works. So at some point, we need to tell OpenGL how we're structuring this data. We could also, I was talking about colors, we could do colors first and then textures. We could do colors before positions. We've got to tell OpenGL what this data is, how it's structured. And so I don't think any of this has changed in terms of our VBO or EBO. I've talked about that in previous videos. But once we get down here, we have an extra Vertex attribute that we did not have before. And we set it up like this. So the, let's see here, 03, if I remember correctly, I don't know, I don't want to say something wrong. Let me review the docs for what all these numbers specifically mean. And so I don't make any mistakes. And so I'll talk about that later. We unbind the array buffer here. Again, standard practice, stuff that you bound before, it's good to just unbind it. Especially if you're talking about inside these functions, right? I'll take a look at that for later in the video, and we unbind the vertex array here. So next we're going to look at the, okay, let's go like this, and look at the shaders. So take a look at the Vertex Shader. We've got this is corresponding to that Vertex Attribute, right? So this is Vec3 for the positions. I'm going to be renaming these, by the way. I don't like that name. Vec2 for the texture coordinates, because they have 2 floats. And you've got a location. This was set in the, what I just showed you, where it sets the Vertex Attribute pointer. I think I could just make this like a 1 instead. I think I'm skipping the number 1. It's kind of arbitrary. And you have like maybe 16 or 32 that you can set. So you're just defining that location yourself. I'm pretty sure. I'll double check and talk about it again later at the end. Text chord. So this out is basically output, meaning the output of the Vertex Shader gets passed down the graphics pipeline. For us, that's just passing it to the Vertex Shader, or sorry, to the fragment shader. You might have other stuff going on, like a geometry shader that does the tessellation, so that can produce new vertices, but that's more complicated. We're not doing anything like that. But anyways, so this out gets passed down, and it will go to our fragment shader, which you'll see soon. Do remember, just a reminder, always have this, sorry, it got weird, this version thing at the first line. It needs to be at the first line. Do not put a line of white space at the top. Now we've got our main function, and GL position is a built-in variable, or whatever it is, it's built in. And yeah, we're just passing through the vertex data right there. There's other ways we can write that, but I'll show you. We'll do a lot of shader stuff later. And text chord equals text chord. You notice that this is lowercase, so it's just being passed through in our main function. That's it. That's it for the vertex shader, and we'll go to the fragment shader here. So we take an in is that text chord. Remember I said that was being passed. as output from the Vertex Shader, and it's being passed in here. We've got the output is frag color. This is basically, I think you can name this whatever you want, but it will see the output and the output of the fragment shader is just going to be a color. So that's it. Now for uniform, but I'm not 100% sure. I'd have to check. Uniform sampler 2D. This is something that samples the texture. So I might talk about this a bit later, but it looks at your image data basically and samples it. I mean, basically, remember the fragment shader is like 1 pixel on the screen. And so for every single pixel, it needs to figure out where in the image that lies. So this little sampler 2D does that for us. Just ignore this. That'll be later. Be making circles and stuff. That's what that's for. And this frag color here is what we had before. Just it was just if you just wanted to output a color and just output a rectangle with a solid color, you can change it to this one. But right now we're doing textures, so it just takes this general texture and text chord and texture, uses this texture function. It's all kind of like built-in functions and stuff here. So the key is just getting it to work. That's about it. And it's making the texture. All right, so I'm going to watch over this and review add the stuff that I said I'm going to add to the video. So talk to you again. Okay, so here's the GL text image 2D I said I would look up here. So I want to show you the docs also here. So Chronos, by searching for various OpenGL functions, you'll come across this stuff. So these are basically the docs that show the OpenGL specification here. Actually, no, this is not the specification. Specification is different. Well, I don't know, maybe I'm getting into semantics. This is basically this is the docs, the documentation. So yeah, specified to dimensional texture image, and we've got, let's see here. So it's here. Target is GL texture 2D. There's other options like, so cube maps are kind of like these 3D kind of textures, if you want to think of it like that. For yeah, I think you can make like something like a miniature kind of skybox and do reflections with a cube map. I haven't done it in OpenGL. I've done it in Unity, but not yet in OpenGL. So I'll try that sometime. But yeah, so there's other targets. Level, GL int level specifies level of detail number. Okay, so this is different. Like if you wanted to generate it for, so I'll talk about maps first. Talk about this stuff first. But before we get to maps, let me talk about this part. The GL clamp to border is what I'm doing, and you won't get any of these other strange effects like you see here. So GL clamp to edge will do that, like you see, and then we've got two different types of repeat, just simple repeat and then a mirrored repeat. So it doesn't really matter that much. I think that clamp to border makes it. Have you ever been using a game engine and you have these kind of weird artifacts happening at the corners between two textures? If you have, you know what I'm talking about. And I think clamp to border kind of makes it more obvious if you're having those kinds of problems. If you're trying to get things pixel perfect. I don't know. I mean, clamp to edge might be good, but that's what I'm using for now, clamp to border. And then we've got this GL nearest thing. And so that's going to be this texture filtering. Here's nearest and here's linear. So you can see nearest is basically kind of pixelated, whereas the GL linear is less pixelated. It's almost like it's anti-aliased. it's sort of blended in. In other words, it is interpolated. So it talks about the difference here. Nearest will, let's say this point, the crosshair you see is what the result of the sampling is. Remember the sampling in the fragment shader? Well, let's say it gets here. Well, in nearest, it will do exactly that, whatever color it landed on. In linear, there will be some interpolation from the neighboring texels. So that sampler that we were talking about before will take probably the results of the fragment above, below, left, and to the right, and blend them, would be my guess there. And so it returns kind of a blended mix. I don't know if it does like the diagonal texels. Texel is just a texture, like a texture pixel, basically. So yeah, I don't know if it does, what exactly it does to blend, but I don't know. Personally, I prefer the kind of crisp, pixelated version. I guess it's a matter of preference. And then we get to mipmaps. I explained it before. They're smaller versions, and each one is half the size of the previous one. So that's a mipmap. So if you here, level of detail, well, 0 is normal. If you only wanted to generate a specific mipmap, basically, smaller version, I guess you would change that. I don't know. I don't bother changing that very much. So internal format looks like it's going to be the RGBA or RGB. I guess there might be other ones. Then we've got width and height. We've got border. This value must be 0. Nice. All right. Format specifies the format of the pixel data. So again, we have GL, RGBA. So I'm not too clear on the difference between these two. I just try to do what makes it work. Wait. Oh, okay. We can have other options like stencil, depth. So we'll talk. Maybe we'll get to that later, stencil and what that is. They do get to that in the advanced part here, I think. So if you didn't know, this is a great resource. I've talked about it in the first video. And so yeah, advanced OpenGL, yeah, they get into stencil testing and depth testing. And so these are different options, and you could use, I think off the top of my head, it might be good for like a bump map or something, doing something different. I don't remember exactly. Anyway, there's other kinds of things that you could do there. But right now we're just doing very simple RGBA. That's it. Then type, let's see, GL unsigned byte. Okay, yeah, you could have, different types of data, like using ints and stuff, but so what we do, I guess this is normal for PNG. I think this is also normal for like JPG files, JPEGs, or whatever. There's a lot of image formats out there, so if you want to do something obscure, you'll have to look that up. What is there, like a PPM is like this really simple format? Anyway, I don't want to get too sidetracked here. And then data is where we actually store this stuff in memory. That's about it for this video. I know there was a lot of content, a lot of work that you have to do just to make textures. Yeah, and so I will hopefully get this working soon, testing it on macOS and Windows. And stay tuned if you want to wait until I have it for Windows and stuff like that. Then simply stay tuned for my next OpenGL videos, and I will let you know. Maybe I'll make a video just for that or something, to show the differences or something like that. I might completely redo this video here as well, so we'll just have to see. And thanks for watching, and if you want to help the channel, of course, liking, sharing, subscribing will definitely help me out. And there's also some links in the description, Patreon and Subscribestar and stuff like that. So thanks for watching. Take it easy.